Okay, so from the gas company, on our example that we have, the gas company stops right here, if you look at the drawing. So it's shy of where we want the actual gas meter. But this line, their pressure is typically called plant pressure because their gas plant is producing a pressure in their system. And they also look at gas load and they compare it to their line size and they look at their pressures in the system based on what's coming off of that system. The more you have coming off the grid, or if they're off their piping, it affects what pressure is still available, because as your demand goes up, then your pressure drops and they have to boost it. Same thing for domestic cold water systems out in the road. But we don't, I'm explaining that, but we don't care about that because it's their job to determine what they have to extend to our site in order to serve not only this space, but they're thinking about more revenue down the road. So this is not the only site that they're going to serve. They're going to serve this building, and so forth and so on. You know, if this road just stops here, then depending on what this line size is, I don't know. I mean, they look at all that, and then if this school has to pay for this extension, as they add customers, then they have a process where they prorate back this owner because they paid the initial cost for that extension. Does that make sense? Yeah. But so 20 to 25 PSI, it varies depending on location. Typically, we ask for 5 PSI leaving the gas meter. So if it's coming in plant pressure, they're going to regulate it and leave at 5 PSI, 5 pounds per square inch. San Antonio requires a max of 2 PSI, and that's just I'm assuming it's a safety issue where they're just trying to maintain a little bit less of a hazard within the city of San Antonio. And then once we get to where we're serving the building, we will zone and provide locations of gas regulators depending on what we're serving and go to less than 1 pound. Plant pressure, gas company extends it to wherever. They may stop down here, and then they provide a line across to where the gas meter is going, 5 pounds, and then we look at our load and we size it based on what we're going to talk about in a minute, gas load and longest run, and then that's going to help us determine the line size going to the building, and then we'll look at zoning what we're serving, rooftop units, water heaters, science labs, everything that's listed over here may vary depending on the building type. You're thinking about owner preferences, you're thinking about are there any future additions? Is this an elementary school, middle school, high school? Is it a career tech center? What all is involved, and then how can I, and I've got a reason for this front and the gas over here and the gas meter over here. Once we get into the building configuration and things to look for, options that we don't want to do versus options we do want to do. Okay, and then this is our typical sizing table. And then this is the list of calculations that I want to try and run through today. They're going to be quick. It's not like it's going to take till 5 o'clock, maybe 4:30. Just kidding. And then we've got the building layout, and I've got footages on there, distances, so that we can determine our longest run, and we can also determine area for future additions based on the 80,000. I went ahead and put an 80,000 square foot area for the original building. And then I'm also indicating, what are these guys?
Points of use.
These are rooftop units. And then I purposely left this one unshaded for a reason. These two right here. These are cooling only, so there's no gas load. These are usually for electrical rooms, IDF rooms, MDF rooms. We just want to cool. There's plenty of heat in these rooms. So if the sensible set point's satisfied, and the unit cuts off, that room's still producing heat. So we're not trying to solve a heating issue. We're trying to make sure it stays cool so it's not damaged. So we don't specify. It's either going to be a mini split like we have in this building or a rooftop, depending on the internal load of the space. At the top where the gas company, their line stops, I'm indicating 600 feet to this meter, this proposed gas meter location. Now, you can see we've got road and we've got street, and I've located the gas meter on the street side, and there's a definite reason why we did that. If we would have come down here and set the gas meter down here, the major gas loads in the kitchen and the generator and the rooftops. So if we would have put the gas meter, we would have asked for it over here, then we would have had the line size based on the same longest run, but now we got to run the main. It's going to stay full size all the way to this side. So you want to think about your line dropping off load as it travels across the building, right? And so the owner would be paying for a 3 or 4 inch line all the way across, and then it would get smaller versus 3 or 4 inch here, and then it would drop down to a minimal load. The other thing is we don't want to set it here or here or here because we're in the front of the school. Although it would be much shorter to extend to there and just set it there. Owners are not going to want to see the gas meter. I mean, it's not going to matter to the gas company because they're still going to need gas down this road at some point. So whether they stop here or down here, they're still going to extend it. So it doesn't make sense to put it here thinking that we're saving money. I mean, we might save money on the extension, but they're going to go ahead and want to extend it here. They're not going to want to extend it 30 feet versus let's go ahead and get it done and plan for the future.
They're going to get paid either way.
Yeah,
Right?
yeah. I mean, they're going to want to extend it, and this owner is going to want them to extend it so that they can get paid back through the additional revenue that they see from the additional customers. So it just makes sense to locate it here where the load is, and then your line can drop down away from the main load. And the reason I've got 600 feet is that when we coordinate with the gas company, we have a kickoff meeting, we find out who the gas company is. Is it CenterPoint or Atmos or the City of San Antonio? And I think there's a couple of others. We will contact them, send them a site plan, come up with an estimate gas load, and then they will let us know whether we've got gas at the site. Because what we don't want to happen is get finished with the drawings, the project bid, and then the contractor starts coordinating with the gas company. All of a sudden it's $150,000 to get gas extended to the site. And first rattled out of the cage, we've got a big change order. And the owner's going, why didn't we coordinate this? And what we do is we coordinate with the gas company, and then we send information to the project manager. They send it to the architect, and then they place that amount in a general contingency fund. Used to, they would break it out and list it. Well, that doesn't work so well when the sub goes, well, I'm gonna come in $1 less than that amount and get as much as they can. So they just put it in there and maybe put some stuff in, a little bit higher than what we tell them, to where they make sure that we have enough money for all the allowances, like test and balance, gas line extension, electrical service. They have to coordinate that as well, because if there's no power down here, we have to extend power. So